So today we're going to finish up the note stuff and then maybe get into some examples, okay, of the Cramer's rule and determinants. Okay, so we finished up class yesterday doing the determinant of a 3x3 matrix and how to find that. Okay, and this results in a number. Just make sure you remember that. The determinant is a single number. So, just so you see kind of an application type problem and something that you will have to be able to do is basically how to find the area of a triangle given coordinates. Still notes. Alright, so area of a triangle. The area of a triangle with vertices x1, y1, x2, y2, and x3, y3 is given by area is equal to plus or minus 1/2 of the determinant. Okay, and across the way this reads is x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, and before you ask me why, it just is. Okay, and then for this, okay, the plus or minus, okay, indicates that the appropriate sign should be chosen to yield a positive value. Okay, so we'd use this if you had a problem that's talking about like a triangular region, maybe between different islands, and wanting to know like what that area is between them or something like that. And we'll do a couple examples with that too, obviously. But the next thing we're going to get into is Cramer's rule for a 2x2 system. Okay, but before that, let me explain a little bit about how we get that rule. Okay, so basically this is a way of solving a linear system. And we're going to be using a coefficient matrix to do so. So essentially you start with a linear system. Okay, meaning just like two equations, two unknowns, like we've been solving. So ax plus by is equal to e, and cx plus dy is equal to f. Okay, then the coefficient matrix that we're talking about okay, it's the numbers that are in front of the variables. So we're going to have the matrix A, B, C, D. Alright, so for a 2x2 system, we're going to let A be the coefficient matrix of a linear system, AX plus BY is equal to E, and CX plus DY is equal to F. So if the determinant of A is not equal to 0, then the system has exactly one solution. The solution is X is equal to E, B, F, D over the determinant of A, and Y is equal to A, E, C, F over the determinant of A. What? No, I just always do that. I don't know why. Like, literally everything I did in college, like, every single proof that I had to do started with, like, let and then some variable be something. And I decided I was going to make let look nice because I had to write it a lot, so. I don't know. And it's nice to just, like, let everything flow together. Once we start doing problems, it'll make more sense, I promise. That's why I've allotted, like, 2 full days for it, so. Yes. Do we? Quiz on Tuesday, I think. So that way Monday's basically a review day for all of this stuff to get ready for the quiz Tuesday. The same day as your math test? Okay, let me show you where these are coming from, okay? Basically, the X values are coming from what's left with the B, E, D, and F, okay? So it's basically the determinant of those values, okay? They're just switched, okay? I will just... Yes. We'll get there. When we do examples, it will be fine. Okay? Alright. Yes. It's the determinant of... that's what I'm kind of getting ready to write, but it's the determinant. Yeah. So if you just write the absolute value bar lines, it means... that's what they look like. That means take the determinant. Basically, like, hey, here's the determinant of a matrix. Like, find it, basically. Numerators for X and Y are the determinants of matrices formed by replacing the coefficients of X and Y with the column constants. So basically, okay, just so you can see what's happening here. Essentially, I want to know what X is, so I'm going to put these 2 values in for X, and then have the B and D copied down for the Y values. So I'm replacing my X values with the answers over here. And then my Y values I copy down, and then I take the determinant of this, so ED minus BF. Okay? Then, for y, I replace the y values b and d with e and f. So then I copy down the x values, a and c, and then I replace y with e and f. Okay? Once we do problems and you actually see it with numbers, it'll make more sense than seeing it with letters. But this is just the general form that it follows. Do what? Well, this is if you're like trying to find what the x and y values are for the system. Like, you'll have specific problems that say, like, use Cramer's rule to solve the linear system. Because there is another way to solve a linear system that I think we do in the next section. Yeah. So the other method we do in the next section, so this is just a different method to do it. Yes. Alright. I will tell you, you do the same thing for a 3 by 3. We're not going to do a 3 by 3. Okay? If this was 3 equations, 3 unknowns, you could do it this way. I'm not going to make you do that because there's a much easier way to do it than using this method. This is just a little bit more practice with determinants. That's why. That way you've seen Cramer's rule in case you're ever asked to use it. But I don't test as heavy on Cramer's rule because it's just a formula basically. So. No. Because I guarantee you've not done matrices before. Alright, so we're going to find the determinants. Yeah, so now we're going to move into examples. Kinda. Alright, so the first problem says to evaluate the determinant of the matrix. Okay, we're doing this by hand. I didn't show y'all yesterday how to do it on a calculator, right? Okay, good. Make you do it the hard way first, and I'll teach you the easy way. Alright, this matrix is 7, 1, 0, 3. Alright, anybody remember how we set up the determinant? So, 7 times 3 minus 1 times 0. So, it's just 21. I mean, you don't have to write it out this way. I would at least like you to write 21 minus 0, though, so that I see what you're doing. So that way, if something is wrong, I know what you did. But you don't have to, like, write out 7 times 3 minus 1 times 0. No, you don't have to do that. 1, negative 3, 2, 6. So how do I set this one up? Yep. So 6 minus a negative 6 is 6 plus 6, so that's 12. It's always minus, yeah. It's always this diagonal minus this diagonal. Alright, I want you guys to do this one on your own. Negative 5, 12, 4, 6. Really hoping I don't spell these everywhere. Smarties. I had a Smartie in like 10 years probably. So Tabitha. At least she'll know that we have candy sometimes. So. Alright, what do we get for this one? Okay, good. I'm making sure nobody was going to contradict each other. Alright, negative 78 was that one. Alright. Pretty easy, right? 3 by 3. I'm on my 3rd page. Alright, 12. 1, 2, 3, 5, negative 8, 1, 2, 4, 3. I'm going to recommend, if you wrote your matrix out, I'm going to recommend you do the determinant below. Alright, I'm going to try to box stuff in colors so we know what we're doing. Okay, I'm trying to use light color so it doesn't like mess everything up. Alright, so the determinant of a 3 by 3, okay, it's this first one, okay, times the determinant of all of that, okay? So it's this top value times the determinant of this, which you literally just did up here, okay? So 1 times, what's the determinant of this 2 by 2? What? You have part of it, right? What's the rest of it? So this is negative 24 minus 4. Okay? Now, what happens to the sign of the second one? It's minus. Okay, yep. It goes back and forth. So this one is going to be minus 2 times. So now, I'm going to box this one in blue. 2. And then these outer 2 columns. So it's a determinant of these ones. (15 minus 2). What happens to the sign of the last one? Back positive. It always starts positive and then it goes negative, positive. Now, if these values were negative, that's different. Okay, we'll do one of those in a minute where one of these values is negative. Alright. That's kind of the same color. Let me use something different. Okay, so the last one is 3 times these values here. So what's the determinant of this box here? Yep, 20 plus 16. I did. This is orange. Yeah. So what do I have here? Negative 28. She's distributing. Do this stuff first. Do what's in the parentheses first. No, I'm not. Don't distribute. 26. So what is that? So, is that right? 108 minus 28 would be 80. Yeah. Okay. All right. We're probably doing a couple more of these ones, but yes. Question? Who said question? You sure? Okay. All right. 15. All right, we're taking the determinant of this one. 14. It follows the pattern positive, negative, positive. But if there's a negative sign, we still have to write it. So the next one is also going to be minus. Okay, because it follows the pattern positive, negative, positive. All right, the middle one, okay, we do the 4, and then the determinant of these outer two. Okay, remember, if you don't understand what's going on, okay, whatever top one we're picking, we're covering that one up. So for the first one, we covered up the stuff that was in that column with it. Okay, now that we're on the 4, we're covering up the middle column and doing the determinant of what's left. Okay? So this is minus. Okay, hold on, guys. Hold on. Okay? Let me explain where we're getting all this stuff from. Okay, so we covered this one up, so I'm taking the determinant of these outer two. So I had 1 times 6, which is 6. Now, it's minus this other value here. Okay, so it's minus negative 4 times negative 10, which is positive 40. So it's minus 40. Okay, just keeping the signs, okay, where they go. So we're doing this one, we're covering this column up and doing the determinant of these other 4 over here. Okay, so what do we get? Here, I would do this first. Okay, I would get to this point first and then try to do stuff. Okay, with one that has like 1, 2, and 3 in front of it, okay, that one was pretty easy, but these ones with bigger numbers, I would recommend doing it this way. Yes, thank you. Alright, 7 times 16. Negative 112. Negative 4 times negative 34. Plus 5 times 21. So what do I get? Okay, we'll do another one in a minute, but do you guys want to see how to check them on your calculator first? Alright. Yes. Alright, go ahead. When you get your calculator out, go ahead and put this matrix in, matrix A. I know, I just brought them too. But I need to get rid of them, so 4. Alright. We have our matrix typed in. Alright, so just so you know, okay, if I give you one and I tell you, hey, use your calculator to find the determinant, okay, what you need to do to show me how you're doing it is you need to write the determinant of A is equal to, and then whatever value it gives you. Okay, that's how I'll know you used your calculator. Yes. Alright, everybody have their matrix in? Alright. You already got the answer? Alright, once you put it in, you're going to hit second matrix. Go over to math. Okay, your first option is DET. Ooh, determinant. And then second matrix, matrix A. Hit enter. Boom. No. Second matrix, math, determinant. No. To check them. But you'd have to show all this work to do that. Make sure all your numbers are typed in correctly. Guys. So this one, so we had 7 times 2 times 6 was 12, and then it's minus a negative 4 because it's negative 4 times 1. So the formula is that it's a negative here. This bottom one is a 6. Yep. Now it should do it for you. Yeah. I'm going to give you an easy one to do by yourself. It's going to have zeros in it. Ones with zeros in them are really, really nice. If I give you one with zeros on your test to do by hand, yeah, you should. Just kidding. I'm just kidding. What? All I've heard is kissing and then zeros and I think hands and... Alright. It can't hear you. They can only hear me. Alright, do this by hand and then check it on your calculator to make sure you did it right. Yes. Yes, you can use colors for this section. Okay, I'd still prefer not like red or pink, but if that's the only thing you have, that's fine. I'll just grade in some other color. You can't complain if I give you one this easy. Yeah. Yes. Nice. Alright, how are we doing? Yes. We're not done yet. But then yes. Alright. Let's check it. What answer did we get? Okay. Everybody sit. Determinant. That way I just know that you did, like, that'll also show me that you did check it. So. Alright, so we did the first number, -4, by the determinant of the rest of this. That very nicely came out to be 0. Then the next one, we do 3 times the determinant of these outer two. And again, this comes out to be 0, so that stuff goes away. Lastly, we have -9, and then the determinant of this stuff. 12 times -12 is -144. Minus 6 times 8 is -48. -9 times -192 is 1728. And then checking it on your calculator, you should have gotten the same thing. Like if this whole row was 0. I would just show like -4 times 0, -3 times 0, -9 times 0. And then just show that it's 0. Not in this class. Might at some point, but not in this class. Alright. We'll be done for today.